Hey guys, so today we're going to be starting our 7th chapter of Math 10C, which is the last chapter that we're going to be doing. This chapter is all about systems of linear equations, which is essentially where you have at least two linear equations or lines that are related in some way. Today we're going to start by going over how to create or write those system of equations. And almost every lesson that we do in the rest of this chapter is going to require you, for at least some of the questions, to do this, to write your own system of linear equations. So this is a really important lesson. So as you're going through this and going through your homework, if you do have any questions, please email me. But the best way to get good at writing systems of linear equations is just to practice it and develop your number sense, which is what allows you to just see how numbers relate to each other. Okay, so let's get into it. Okay, so this is lesson 7.1, making systems of linear equations. For each of these, you're going to create two linear equations to represent a scenario that you've been given. Each equation should have the same variables. There will usually be two variables per equation, though the odd time you might see three. And you always want to start with what's called a let statement, which tells you what the variables represent. So we'll go through this first example here. It says vans carry 8 people, SUVs carry 6 people. A group of full SUVs and vans carried 110 people. There was 15 vehicles in total. Write a system of equations. So I'm going to start with my let statements. I'm going to say let V equal the number of vans and let S equal the number of SUVs. I know that these are going to be my let statements because I know how many people can fit in each SUV and van. I know how many people and how many vehicles in total there were, but I don't know how many of each there were. And so now that I have this, I can create a relationship between them. So the easiest kind of part of this to write an equation for is this sentence right here. There was 15 vehicles total. That tells me that the number of vans, which I've said represents V, and the number of SUVs must add to 15, because that's how many vehicles there was in total. The second statement or equation that I'm going to write is a little bit more complicated. It has to include both how many people are carried per type of vehicle, as well as the total number of people that went wherever this convoy was going. So the way I would show this is 8 people times the number of vans, because each van can hold 8 people, plus 6 people times the number of SUVs, since each SUV can hold 6 people, will all add up to the total number of people. Okay, so those are the two equations that we would end up with. Those two equations are what makes our system of linear equations. Okay, let's try another example here. So this one says you get 10 cents per can and 25 cents per bottle that you bring to the recycling depot. You bring 2,000 bottles and cans and you get $185. So once again, I'm going to start with my let statements. I'm going to let B be the number of bottles and C be my number of cans. And then again, the easiest thing is to just identify my total number of bottles and cans. that tells me that the number of bottles plus the number of cans must all add to that total number of bottles and cans. So B plus C equals 2,000. The other one has to do with money. So 10 cents per can and 25 cents per bottle has to do with money. So does the fact that I'm getting $185 in total. So I'm going to write this out as 10 cents per can and 25 cents per bottle equals the total amount of money. The one thing you want to watch for here is that you're using the same unit of money. So I have cents, and dollars. In order to make these all the same, I can turn 10 cents into $0.1. So 0.1 per can, so 0.1 times the number of cans, plus 25 cents can be written as 0.25, a quarter of a dollar, times the number of bottles will give me the total amount of dollars that I earned by doing this. Okay, so that's all you're going to be doing today, is just writing out your system of equations, and then sometimes you'll be given a solution to verify, but you're not creating your own solution or solving for your own solution today. That will come over the next couple days. We'll start working on different ways to actually solve these systems, but not today. So the one other thing that we're going to do today is look at how to verify a solution that you've been given. And this will come in handy once you start calculating your own solutions. You can always use this method of verification that we're about to go over to check your answers anytime you solve a system of linear equations. So let's look at how to do that. Okay, so these are the things you have to keep in mind when you are verifying a solution. First of all, you must verify both of your linear equations. Sometimes you will have a solution that works for one and not the other, and the solution isn't right unless it works for both. So always check both equations. We're going to verify a solution by using something called left side equals right side, LS equals RS for short. What you do is you plug the solution into the variables and then solve each side individually. What I mean by solve each side individually means that you shouldn't be isolating anything, you shouldn't be gathering like terms, you shouldn't be moving anything from one side of the equal sign to another. You're just solving each side of the equal sign on its own. And in the end, if the stuff on the left side of the equal sign is equal to the stuff on the right side of the equal sign, then your solution is verified and you say left side equals right side. If the left side of the equal sign does not equal the right side, then the solution is wrong, and you say left side does not equal right side, like this. The does not equal sign, for those of you that don't know, is just an equal sign with a slash through it. So let's look at an example of how this would work. So in this example, it says my dinner cost 3 less than twice as much as my lunch. My lunch and dinner cost $48 total. Verify that my lunch was $17 and dinner was $31. So in this case, you're not given the equations, so you are going to have to start by writing out what the equations are. So this first sentence here, my dinner cost 3 less than twice as much as my lunch, that's going to get turned into one equation. And then this next sentence, my lunch and dinner cost $48, is going to be my other equation. So I'll start with my let statements. I'm going to let D be the cost of dinner and L be the cost of lunch. And then I'll write out my two equations. The easiest one is this orange one here, that the cost of dinner plus the cost of lunch is $48 in total. The other equation is slightly more complicated. So the cost of dinner, so my dinner is, or is equal to, 3 less than twice my lunch. So twice or 2 times the cost of lunch, and then I show 3 less by subtracting 3. Okay, so my dinner is 3 less than twice my lunch, or double my lunch, or 2 times my lunch. Okay, so that's the other equation. A common mistake here is because it says 3 less than twice, people think I have to put the 3 before the twice, and they'll go 3 minus 2L, okay? But it's 3 less than twice my lunch. That means I have to figure out what twice my lunch is and then remove the 3, okay? So just keep that in mind. Okay, next up, I'm going to actually move on to verifying this. So I'll start with the first equation, D plus L equals 48. And I'm just going to plug in the solution it gave me, where lunch was 17 and dinner was 31. So my D is 31 plus 17 for my L equals 48. And then I just do 31 plus 17 is 48. I now have 48 equals 48, so I'll say left side equals right side. So I have verified that the solution works for one of the equations. Let's check the other one now. So the second equation is D equals 2L minus 3. Once again, I'll plug in my D of 31 equals 2 times the lunch value of 17 minus 3. So 31 equals 2 times 17, which is 34 minus 3. And 34 minus 3 is 31. So I once again have left side equals right side. As soon as I see these two left side equals right sides, then I have verified my solution. So that means that the solution of the dinner being $31 and the lunch being $17 was correct. Okay, so that's what you'll be working on today.